Welcome to this session on IP addressing. We are not going to go into the details of every part of this IP addressing in this lecture. This is going to be an introduction to IP addressing. Later lectures will have much more details about what are the classes, different classes of network addressing, as well as classless addresses will be taught in very much in detail. Okay, so there are two IP versions, IPv4, IPv6, and just to get it into context, we have a OSI layer, open system interconnection. Physical layer is the bottommost one, which worries about bits traveling over the network. It could be an optical connection or Ethernet connection or a wireless Wi-Fi connection. Then we have a data link layer, which is L2, and physical layer is L1, and data link layer worries about how different sub hosts connected to a LAN interacts. What are the unique addresses in them in a LAN and how they exchange information. And then we talk about IP addressing, which is the network layer in the L3 level, which is about IP addresses. So in the network layer, we have the whole internet, which are interconnected networks, and they have hosts and they talk to each other. Now, if suppose a LAN has different hosts, they will have two addresses. Of course, any machine which is connected to internet will have two addresses, which is one is physical address that refers to the MAC address or media access control address in the L2 layer, which are visible within the LAN. Now, it's not that MAC address is not known outside, but what I'm saying is the MAC addresses are of concern when you need to talk to devices within a LAN. And then when you want to connect multiple networks, list LAN 1 and then there is another LAN 2, they will all be in two different networks and we need a router in between. It can be one or many, which will be routing the packets from one network to the other network. So if you need to communicate with the hosts which are within the same network, we use it within the LAN, and there will be switches which is taking care of them. And then when you want to talk to hosts which are on different LANs, then we need a router in between, which is a network device that understands IP addresses, and they route the packets to make sure that the packets which are meant to some machines which are in the different network to be delivered to the host. So what we are going to talk about is how do we define the addresses of IP, Internet Protocol, which runs on the level 3 of OSI layer. We are not going talking about anything about that in this lecture. Now let us see what is the difference between IPv4 and IPv6. There are two different versions of IP addresses. This is a 32-bit address and this is 128 bits of addressing. And again, we are not going to worry about IPv6 now. Let us only discuss IPv4. Now, when I said that IP addresses are for machines which are on different networks and they need to be uniquely identified, then these IP addresses have to be unique in the entire internet. Now, I also mentioned about the MAC address, and which is a physical address. So when any machine, it could be a laptop or a desktop, to be connected to a network, based on what type of network you are connecting to, either optical network or you are connecting to Ethernet or a Wi-Fi, we need a PHY, which is physical interface or a network card on the machine to make this machine compatible and connected to a network. So each of those network cards that are there inside a machine needs to have a unique MAC address which is decided by the manufacturer and put into the network card, which is not going to be changing after the manufacturing is of that network card is done by the company. Now how big that MAC address is? It is a 48-bit address, which is understood by the data link layer. Either it could be an Ethernet MAC address or a Wi-Fi MAC address, or even if your mobile is connected to a Wi-Fi network, each mobile has a MAC address which is decided by the manufacturer and it's not going to change over time. Whereas the IP addresses are not of that type. They are logical addresses. IP addresses are logical address. They are not physical address. That means what? Based on the network a mobile is connected to, it may have different IP address. Now let me give a scenario where you have a mobile, you are in your home and you are connecting it to the Wi-Fi of your home network. Now what happens is this Wi-Fi router what you have at home gives you some IP address to your machine for that particular communication that you are having. Once you come out of maybe data is switched off or you are out of this range of Wi-Fi, then it's not going to use the IP address assigned by the Wi-Fi. So this IP address assigned by the Wi-Fi router, which is given to you on temporary basis as long as you are connected to the network in that section. Now you move to maybe airport, connect to a free Wi-Fi available there. Then that Wi-Fi router what is there in the airport gives you an IP address for you to be in touch with the rest of the world, because as I mentioned, the IP addresses have to be unique in a network, in an internet, for you to be connected to the network. So you connect to a Wi-Fi, any website, or you connect to YouTube and stream some video. All that while happening, you are assigned to some network locally, as well as it is visible to you, visible across, that you are able to reach any other website or even YouTube or anything can stream some video to your mobile. So you need to have some IP address for it purpose, and that is given by the nearest network that you are connected to, and the IP address is decided by the network you are part of. Either you are part of Wi-Fi at home, or you are part of Wi-Fi in the college or at the airport, or maybe you are connected to a college network through a Ethernet port in your laptop. Then also you are given an IP address based on which network you are part of. Now you can be in any network, right? As I told you, based on where you are connected to, your IP address is based on the network you are part of. Imagine a situation wherein you have a home Wi-Fi and you are having an IP address, and for some reason the Wi-Fi ISP, internet service provider, has not given you an internet connection, maybe for because of some reason. Then what happens? You get into a 3G or 4G, you are connected to the network that you are connected, maybe Jio or Airtel or Vodafone, anywhere you are connected. You are directly accessing the data or internet through your 3G network or a 4G network. Then your service provider, the 4G, 3G, 4G service provider is giving you an IP address. So that will be different from what you got from Wi-Fi. So somehow you are reaching the internet, and the first network you are connected to is what the network IP address that you are assigned to, and you use it for your transaction during that time. So there can be at the different point in time, your same machine may be having different IP addresses based on which network it is part of. Now let us talk about one particular IP address. And as I mentioned, we are going to talk about IPv4. That means the IP address is 32-bit wide. So when you are having an IP address, it has got two parts to it. Why? As I mentioned, as you are connected to a LAN, local area network. It could be created by a Wi-Fi in a home, or maybe it is in an airport or whatever maybe, or in a college, you are connected to the LAN first, and then it is connected to some other network through a router on the way. So within the LAN, the IP address is decided by the particular network you are part of. So any address given to you will have two different parts to it. One is the network you are part of, and different host. I call that as a host. Any device connected to a LAN is a host. It could be a printer, or it could be a mobile phone, or a laptop, or a desktop, or even a small IoT device. Doesn't matter. They are considered to be a host in a network. So if multiple hosts are connected to a LAN, a local area network, all those hosts in the network will have a common network ID, and the host ID will be unique for each of those devices. So this is the division. It is true in the case of IPv4 for sure, and I will talk about later on about IPv6 in the later lectures. But now let us bother about only IPv4, wherein 32-bit address you have, and you need to have a division of network ID and host ID port. Now, what is this actually? Now, let us see three different divisions of this network ID and host ID portion, and then understand what is the difference between them. How does that give you a flavor of how these divisions really give you different configurations. Now, suppose all of them are 32-bit wide, and then I say that your network ID portion is only 8-bit and your host ID portion is 24-bit. That's one way of dividing the address. Another way of dividing, maybe I'm just dividing it at the byte level. I'm not going into bit level in this case. So then 16 bits are reserved for network ID. Always remember the first one what you see. When I say first one is MSB, this is LSB. Always remember that. And then this is host ID. The remaining 16 bits are for host ID. Other possible combination of dividing it into byte boundaries is network ID is 24 bits, and the host ID is just a 8 bits. Now, how do they differ? The network could be of this type, or it could be of this type. Maybe this network could be of this type. So, in the IP world, these fixed divisions of network address, IPv4 address, into two parts on byte boundaries are given a specific name. This is called class A addresses, this is called class B addresses, and this is class C address. Now what are they differ? How do they differ from each other? If you see that number of bits reserved for network ID, it gives you an idea of how many networks of different type could be there which are part of class A. Okay, different networks. I'm saying internet has millions of networks. So if a network is of type class A, 8 bits are reserved for network ID, which is bit 0 to bit 7. 8 bits are there. It could be all zeros to all ones, but not all the combinations are used in the network ID portion. Some are in the top portion, some are reserved for encoding the class A type of address. We'll not go into the details of that, but what I'm saying is maximum 2 power 8 networks can be there, unique networks. And then how many hosts can be there in the network? It's 2 to the power 24, because 24 bits are reserved. 2 to the power 24 different hosts can be there in a particular class A network. But not all the addresses of hosts are valid, because this 24 bits what you have in a class A address, all zero combination is not used for a valid host IP address, host ID. Okay, it's not a valid host ID. Similarly, all ones of this 24 bit are not a valid host ID. Now, why is it reserved? The reason being, we need some way of addressing all the devices in a LAN. Because I also told you that host ID is relevant within a particular LAN. So, IP addresses are used to address those devices in a LAN, and there may be a possibility that, or not a possibility, there is a requirement that the administrator of a network wants to convey some common message to all the hosts in the network. It's like a broadcast saying that this is the thing that you are supposed to do, or this is what is happening in your network, some information sharing. So some address like all ones for host ID is reserved for a broadcast address. Okay. As you understand, IP addresses are to specifically address a host, and when I put a network ID which is specific to the particular network that I am part of, and then I am sending a message with this all ones, means whatever message I am sending, that packet needs to be received and processed by all the hosts in the network. So that broadcast address is reserved, that host ID is reserved. So what you have the remaining is only the other combinations of bits in a particular host ID part of it. So if you want to know in a class A address how many hosts can be there, it is very easy to deduce that it is 2 to the power 24 minus 2, because two addresses are taken off and you have the rest of it to be given to the devices or a host connected to a particular LAN. Now what about class B? Here what you do, you reserve more space for host ID, network ID portion, and equal amount of bits are reserved for host ID portion. That means you can have to put to the power 16 around. Okay, networks of different class B can be there, and then you have 2 to the power 16 hosts minus 2 of course are the different hosts or network devices that can be part of a class B network. Now what about class C? You are giving more space or bits for networks. That means class C type of networks in the whole world can be 2 to the power 24 max, but each of them are only 2 to the power 8 minus 2 hosts in the network. So basically what is the broad level view of these addresses? As you can understand, class A networks are less number of networks that are possible, 2 to the power maximum max. Class B networks in the whole world could be of 2 to the power 16, whereas Class C type of network are 2 to the power 24. That means these Class A networks are less number of networks. Such networks are there, but you have 2 to the power 24 hosts can be there. That means you have a less number of Class A networks, but many hosts can be there in part of it. Whereas here equal number of networks of that type, equal number of hosts also can be there. Whereas class C networks are number of networks are more, but the hosts that can be there in another less. 2 to the power 8 hosts only can be there. Okay, this is the network portion, and 2 to the power base network means you have only less number of hosts. That means when you have a requirement of more hosts to be connected, many number of hosts need to be connected, large LANs, then you go for class A address. When you have a 2 to the power 16 is a medium number of hosts that are connected to be connected in a LAN, you go for a class B type of address. And then when you have not more than 200 kind of hosts in a network, you go with a class C kind of network, because these are all different kinds of network. You can say that it's a group of hosts which are there in a particular LAN, where they can be very less in class C, and then medium in class B, and very large number of hosts can be there in a class C network. So based on this IPv4 address, which is 32-bit, okay, maximum 2 to the power 32 IP addresses can be there, and we are dividing it and using it in a different fashion. Okay, so that's how the IP addresses are divided and used. So before I end this section on basic IP addressing, understand that we have divided them into two portions, and one is an MSB part. From there you come here, and at some byte boundaries here we are saying it's a network ID portion of the address, and then the host ID portion of the address is remaining till the LSB. So when you have such IP addresses, during the routing or final delivery of them, not even during the routing, final delivery of those packets need to be given to a particular host. When a packet reaches a network, a packet IP packet is reaching a LAN, and then you need to now decide how do I deliver that particular packet to which host. I need to have a clarity on that. Now how do I do that? Unless I have a clarity on what is the division of that particular LAN, the IP address, I will not be able to extract out the host ID portion, right? So I don't know whether the LAN that I am reaching is a large LAN, which is a class A type, or a maybe medium a LAN, which is a class B of type, or a small LAN, which is of class C type, right? I can be reaching any of these networks in the internet. Now, once the packet reaches, based on the type, I need to divide the IP address into two parts to identify the host ID portion so that I can deliver the packet to a particular host of interest. So I need to have an understanding of how do I divide the given IP address into host ID portion and the network ID portion. That is where the subnet mask comes. Subnet is you are dividing a network address into a subnet. Okay, in this kind of class A class B address, you are very aware that it is on byte boundaries. Only thing is whether it is 3 bytes are reserved for a network ID or 2 bytes or 1 byte, you don't know. Remaining is host ID. So that gives you a mechanism of dividing an IPv4 address into two parts using subnet mask. Now let me take an example of a class A address wherein we have decided that the top 8 bits are reserved for network ID and the remaining 24 bits are reserved for host ID. Now what should be the subnet mask? Let me explain what is the purpose of it. Now IP address could be any number. Okay, it can be some bit combinations here and some bit combinations here. But I need to extract out which is the network ID portion and which is the host ID portion. Basically, once I extract out the network ID portion, then I know the remaining things are all host ID part. So the subnet mask actually gives me a value which is all ones, which is in hexadecimal FFF. If I am writing it in a binary form, it will be like this, right? So if suppose I am dealing with the class A address of IP network, then my top 8 bits will be, my subnet mask will be 1, and then I take this are all 1 each byte, okay? And this is 1 byte which is expanded as a binary form. So my subnet mask will be, in terms of hexadecimal, it will be FF, but if I convert it into a decimal form, because IP addresses are written as decimal numbers, 0.0.0. This is the subnet mask of a class A address. Now, how do I represent it in some form? Maybe, suppose if I say 10.0.0.1 is my IP address. Let us, for a discussion, let me say that this is the IP address. If I represent it in the dot notation form, it actually means that I am reserving 8 bits for each of them. So if I have to expand it into a binary form, it will be 000, okay, and 10 is 10, so this will be 8 plus 2 0, and this will be again 8 bits of zeros, and this is 8 bits of 8 binary bits of 0, and this is 7 zeros followed by 1. So this 10 corresponds to the network portion of the address. Now I want to extract out this bit pattern. How do I do it? Unless I have all ones, which is the 255 that I wrote here gives me a subnet mask, and then I write all zeros here. If I do a perform an AND operation, okay, binary AND operation, I get the same value which is there, okay. I get the same IP address 10, I get it back. So my network ID is 10. What will I get here? Because I am interested in only the network ID portion. I'm not interested in host ID portion in this case. Then this will be masked off even if I have some other number in my IP address. Remember that any address can be there as IP address. Only subnet mask gives you the number of ones which are from MSB part to the point at which the network ID portion stops. In my class A address, it stops at 8 bit boundary starting from MSB. So I get a 10 as a network ID. Now suppose if I have a class B address, as I mentioned, if you remember, it is divided into 16 bit each. Now what would be my subnet mask? It is very easy to remember. Its bytes are divided and then I write in a decimal form. So it is 255.255, right? Because I am interested in extracting out the top 16 bits of the network ID, and of course this will be 0. This is my subnet mask for class B address. Now, how do I represent it in another form? Suppose I have an IP address which is class B. There is a slash notation which says that slash 16 is for saying that from the MSB portion I have 16 bits which are all ones. And then I use this to and it with the IP address. IP address can be of any combination. Please don't think that this will also be all one. Then you are not going to have any valid IP address, because you need to have different combinations of number patterns. Except maybe in the host ID portion, I told you that all zeros and all ones are not used for IP addresses. So you may use all other combinations to give a unique IP address to a host. So you extract out a subnet portion, network ID portion using the subnet mask. So this is for class B network. And if I have a class C network, then you know that the top portion 3 bytes are all reserved for network ID, and the bottom for host is only 8 bits. So you know that it is 255.255.255.0 is my subnet mask, and slash, by now you know the number of bits I am reserving for subnet mask is 24. Slash 24 is a slash n notation of saying that an IP address followed by slash 24 says that I am looking at the class C address. An IP address slash 16 tells me that I am looking at a class B address, and my network ID portion is top 16. The MSB portion is a network ID. So by now I think you would have understood the purpose of subnet mask to extract out the network ID portion, and we are only talking about dividing it into byte boundaries. It could be that I may divide it in between any type. I will come to that later. Right now, this is where we stop and we try to understand a network built with these kind of class B, class A networks, how they function. Okay, see you in the next lecture. Bye bye.